Hi guys, today I'm going to give you some hopefully helpful hints on how to do some more solving of linear equations. These are going to be very similar to ones that you're going to see in the homework and ones that you've read about in the textbook. Always just kind of seeing them done in different ways can help. So there's multiple ways you can kind of attack solving a linear equation. So I'm just going to kind of go through how I would think about solving some different linear equations throughout this. And then we're also going to look at some percentage problems at the end, like you'll see in the homework and the activity, and also a linear model example. We've done lots of linear model examples, but just doing another one today and adding in some of the stuff that we've done now with solving linear equations to look at those linear models, okay? So that's what you're in for, and we're going to start here with this first example where we're taking 2 times x minus 4, and that's equal to 6 times x minus 2. So we want to solve for our unknown variable, which is x. The first thing you're always going to have to do in solving linear equations is if you have parentheses, make sure you get rid of them first. So we're going to distribute on both sides of the equations to just simplify the sides individually, okay? So we'll take 2 through x minus 4. I'm going to zoom in a little bit here so we have some more space. Oh, okay, that's as far as I can zoom in. Okay, so we have 2x. Let's see here, make that a little smaller. There we go. We have, let's start that over, sorry. Okay, 2x minus 8 when we distribute the 2, and that's equal to 6x minus 12 when we distribute the 6. All right, now once you've gotten rid of those parentheses, because the x's are now not trapped in parentheses, I can start to combine my x's on one side of the equation and my numbers on the other. So we've gotten down now to a point where we're a little bit more familiar with this type of linear equation. I like to move my x's to the left, so I'm going to subtract 6x from both sides. To move an entire x term, you'll always add or subtract. So subtracting 6x from 6x will leave me with 0. That will leave me then with, here I will have negative 4x from taking 2 minus 6x. I'll bring that negative 8 alongside, and that will be equal to negative 12. Then again, since I decided to move my x's to the left, I will move my numbers to the right. I am subtracting 8 there, so I need to add 8 to both sides to get that to be 0 and cancel it from the left side. Now I have that x term alone, and it is equal to negative 12 plus 8, which will leave me with negative 4. This is when I need to divide. Always take the negative and the number. We're dividing because negative 4x is negative 4 times x. To undo division, or sorry, to undo multiplication, we will do division. That cancels to be 1 times x, so that is just x. And negative 4 divided by negative 4 is a positive 1. Now, just like in the other ones, we can test that back in the original equation here. I can check to see if this works. I can check to see, does 2 times 1 minus 4 equal 6 times 1 minus 2? That means 2 would have to be times negative 3, and that would have to equal 6 times negative 1. Negative 6 equals negative 6, so that does check out. So you can always check these final answers to make sure that you haven't made any mistakes along the way, right? The more complicated the linear equation, the more chance there is for mistakes. So checking your work as you go isn't a bad idea. All right, let's try this next one here. So now I have some fractions to deal with. So I'm going to kind of show you how I would deal with the fractions. Now, a first step you could take, and not a bad step to take, is to say, okay, I've got my x term sitting right here, so I can move this 5/14 term to the right-hand side by adding it in order to get the x term by itself. And that's actually what I would do first. So I would add 5/14 to both sides. Now you can grab a calculator and do this fraction addition, or you can do it by hand by getting a common denominator. I would say at this point you can rely on your calculator. That's totally fine. So even though this is a fraction, it's not connected to x, so I can just simply add it to the other side to move it. That will make this 0. We'll have x divided by 7 left on our left-hand side, and that will equal whatever 1/7 plus 5/14 is. You can think of 1/7 as 2/14, right? So 2/14 plus 5/14 will give you 7/14. You could go ahead and simplify that right now, or you can just wait until the end to simplify your final answer. That's what I like to do. Okay, at this point now, x is being divided by 7 right here. So in order to undo division, I would, sorry, didn't mean to erase that 7. I would multiply by 7 on both sides in order to undo that division by 7. So canceling out that 7 then, because 7 over 7 is 1, x then is equal to whatever 7/14 times 7 is. Okay, you can cancel there, you can plug it into your calculator, right? The 7 and the 14 have a common factor, so those would cancel down, and we would end up with a final answer of 7/2. I would highly suggest pausing and checking that answer. Okay, put it back into your function, use your calculator to check it. You're just going to take 7/2. Put it in fraction form or put it in parentheses. Divide it by 7, subtract 5/14, and see if you get the right answer. I am going to also double check my answer before moving on. Okay, so you end up with 1/2 then divided by or minus 5/14, and you end up with 1/7, which is the correct answer there. So you can always plug it back in to check your work. Always just use your calculator to check that work. You don't need to be doing that fraction math and stuff by hand at this point. All right, the next one is 5/6x minus 2/3 equals 1. So another one with some fractions that we're seeing, and we can look at another way to handle this. Okay, so you can pause this and give it a shot, especially if you've already read through the section, which hopefully you have, and see if you can get this. Okay, if I were starting this out, again, I see this term entirely separately from my x term, so I'm going to move that to the right-hand side by adding 2/3 to both sides. That will leave me, that will cancel that term there, that will leave me with just 5/6 times x equal to 1 plus 2/3. Thinking of that as 3/3 plus 2/3, you will get 5/3 there, or plugging it into your calculator, either way. One thing to note here is don't round at this point. Always use those fractions. Don't round until the very end if you're going to round at all. But the best method is to always just keep the simplified fraction all the way through. Now we talked about this type of problem back in 8.2. When we have a fraction, we can think about multiplying by 6 and then dividing by 5. Or you can just think about, okay, we have a fraction times x here, just divide both sides by that fraction and let your calculator do the work here. That would cancel. When I take anything divided by itself, it becomes 1. And then x just equals whatever we get when we take 5/3 divided by 5/6. So grab your calculator and type in 5/3 divided by 5/6. Just remember, if you're using a calculator, make sure you put this in parentheses and this in parentheses separately, okay? If you do that, you will get the correct answer, which is 2. And again, you could plug that back in for the x here and double check your work, but the answer here should be 2. You can take a second to pause and check that work as well. Okay. All right, let's see what to do with this next one where we have some more fractions and a couple of x's going on, right? So we're gonna have to combine x's, move stuff around. Always the first thing you want to do is if you see parentheses, I like to get rid of those first, okay? Although, as I'm looking at this, like I said, equations have multiple different routes. So one thing you could do almost that would work, I think, just as well is get rid of the fraction first. Notice this entire left-hand side is being divided by 6. So what you can do from the beginning, let me just rewrite this so you can really see what I'm doing here. This entire side is being divided by 6. So what I can do is multiply both sides by 6, and that will cancel. Since the entire side is being divided by 6, I can do that first. That's a good way. If you have any kind of just a number by itself, that's a good way to get rid of fractions and not have to work with fractions anymore, right? So I like that as a first step. So then we have just the numerator left on the left-hand side, and then negative 2x times 6 will give us negative 12x there, okay? Then still we're gonna have to get rid of those parentheses, right, to start combining some x's together. So take that 5 through the parentheses. We'll have 5x minus 15. Don't lose the signs there, and that'll equal negative 12x. Now before, let me make sure this x actually looks like an x. There we go. Oh, kind of. Okay. Now before I had said I tend to like to move my x's to the left, but we have a single x term by itself here on the right. So let's just move our other x term to be with that x term. So we're going to subtract 5x from both sides in order to move it. Again, to move entire x terms, you add or subtract them. Again, I'm doing that just to simplify the number of steps, because that will then leave me with only numbers on the left and only x terms on the right. Negative 12 minus 5 will give you negative 17. And then at this point, we have negative 17 times x. So in order to undo multiplication, we will divide by negative 17 on both sides. Now, this is a really good example of when you have a fraction here that I would leave as a fraction. Leave it as a simplified fraction. Now, the negatives will cancel. Negative 15 divided by negative 17 is 15 over 17. But other than that, 15 and 17 had no common factors. So that is our final answer for x. It doesn't matter that x was left on the right-hand side. This equation still tells us that x equals 15 over 7. We have x by itself. Okay, so a good way to handle any kind of start with a fraction where you have just a number on the bottom is to just multiply through by that division to get down to just a simpler linear equation. All right. Now this one has kind of a same approach that I would take. Notice we have, again, just numbers in our denominators. Now they're different numbers though, but that's okay. You can multiply by both of them. And you can even kind of combine that into one step. So let me again rewrite this here so you can really kind of see the steps I'm taking. So what I'm saying is, okay, as I'm looking at the right-hand side, I would think, okay, let's multiply this side by 2 and multiply this side by 2 so that this division by 2 cancels. Okay, now you just have to be careful when you do this because that 2, what you're looking at is multiplying by 2 over 1, and that 2 is getting multiplied through the numerator. Now that's totally fine, and then my next step would be to multiply by 3. But what I'm going to do is show you how to combine that into just one step, because if my first two steps are to do 2 multiplications by 2 numbers, I would need to multiply by 2, and then in order to get rid of this denominator, I would need to multiply by 3. So if I need to multiply by 2 and 3, I can do that in one step, essentially multiplying by 2 times 3, which is 6. When I multiply by 6, I cancel both those 2's and 3's at the same time. On this side, the 2 cancels from the 6, and I'm really just taking that 3 through my numerator. On this side, the 6 and 3 canceled to make the 6 a 2, and I need to take the 2 through my numerator. Okay, make sure you take whatever you're multiplying by and distribute it through your denominator. Very important there. Okay, so a couple different ways to think about that problem, and I would definitely kind of tackle it like that first. Get rid of those denominators first so you don't have to think about a bunch of fractions in there. Okay, so we'll take 3 times 9, which is 27x, and 3 times 7, which is 21. So we've got 21x plus 21 equals 2 times 7 is 14x, and negative 9 times 2 is minus 18. Now at this point, we've seen ones like this before, right? This is where I would move my x's to the left-hand side by subtracting an x term to move it. That cancels the x term here. 27x minus 14x would leave us with 13x plus 21 equals negative 18. And that's when then I would move my numbers by adding or subtracting to the other side. Okay, we'd have to subtract 21 to cancel a positive 21. Bringing that up here, we have 13. Let's see if I can make that a little cleaner. Bringing that up here, we have 13x equals negative 18 minus 21, means we need to add those numbers together, so that's negative 39. And then we have 13 times x, so we will divide by 13 to make that a 1 and cancel it away. X will then equal -3 when you take -39 divided by 13. We did a lot of stuff there, so that's a good one where you could pause and double check in the formula and make sure 9 times -3 plus 7, when you divide that by 2, does it equal the right-hand side when you plug in -3, okay? Always a good idea to check along the way. All right, got a couple more for you to look at here. This one, I want you to kind of use that idea that we had back up here, right? Remember we needed to multiply by 2 and 3, so we multiplied by 6. Think about what you could multiply this equation by in order to cancel the 3, the 5, and the 15 all at once. Did you figure out what that number should be? It should be 15, right? I need to multiply by 3, okay, but I also need to multiply by 5, and 3 times 5 will also cancel the 15, right? Because the 15 is what we get when we take 3 times 5. So let's see how that works. You want to multiply both sides of the equation by 15. So I'm going to rewrite it so we can really see what's going on again here, okay? Give me 1 second to get that done, and you probably need time to write this down in your notes as well. Okay, now we have a subtraction on the right-hand side. This entire side, when I multiply it by 15, it means this fraction gets multiplied by 15, and so does this fraction. It means also that this side gets multiplied by 15. So I'm going to write this out so it's a little bit clearer, hopefully. Now, when I get 15 times my 3m minus 4 over 3, that's when I've multiplied my first fraction by 15. I haven't simplified anything yet. I'm going to do that in the next step. I really want you to understand what's happening here. Minus 15, and that 15 again needs to get always distributed through your denominator. So we've got 15 over 5 there for the second fraction. We're going to reduce these here in a second. Okay? Now that's equal to, on the right-hand side, we've got some awesome simplification that happened. 15 divided by 15 cancels, and we just have a 4. But the whole reason we took and multiplied by 15 on the left is because 15 over 3 becomes 5, right? 15 cancels with the 3, and we have the 5 left. So this equation is actually 5 times 3m minus 4 minus, and 15 divided by 5 here becomes a 3. So minus 3 times 2m plus 3 equals 4. So again, multiplying through by that least common denominator here can really help simplify some ugly looking linear equations from the get-go. All right, now at this point, we're looking at something a little bit different, but we know we should have hopefully an instinct by now that we see parentheses and we know we need to distribute to start simplifying those. So here I would get 15m minus 20, and then make sure you take the negative with the 3. So minus 6m minus 9 equals 4. Okay, I'm running out of space, so I'm going to go over here to the right. What we're going to do here, though, is we have negative 15m and negative 6m on the same side. Don't start adding and subtracting them over. They're on the same side. We can simplify this expression. 15 minus 6 is 9m. Okay, so we're bringing that up there. Now, again, we have negative 20 minus 9 on the same side. Those combine to be negative 20 minus 9, which is negative 29. That's all equal to 4. The equal sign stayed where it was. I didn't move anything across the equal sign. I simply simplified my expression that was all already on the same side of the equation to get down to 9m minus 29 equal to 4. This is where we're pretty familiar with this type of equation, hopefully now. We can add 29 to both sides. 9m will equal, let's see, that's 33. Divide by 9 on both sides. And again, always use a simplified fraction where you can. So plug this into your calculator to get the simplified fraction, or realize there's a 3 in both of these terms. It'll cancel, giving you 11 over 3. So your final answer should be that your m equals 11 over 3. That's what your missing variable is. Okay, One thing to note here too is that all these steps were the same, even if we're working with a variable other than x, right? X is just our typical variable. Here we see an m, that's all right. Okay. One thing I also want to note here in this next one is that all these same steps work the same with decimals. It's just that if you have decimals, then you're going to give decimal answers along the way. So look at this the same way you would look at it with whole numbers. I have a fraction with a constant in the denominator, so my first step is going to be to multiply both sides by 2.8 to cancel that division by 2.8 on the right-hand side. Once that division is canceled on the right-hand side, I'm left with my numerator, which is x minus 9.7. Now you're probably going to need to grab a calculator to figure out what 1.96 times 2.8 is. Keep all the decimals, don't start rounding. That is 5.488. You will then be able to add still 9.7. It's being subtracted from x, so we can add to undo that subtraction. It's all right that it's decimals. We're working with them just like regular numbers. So we will then add 9.7 to 5.448, and our final answer, unrounded, will be 15.188. Okay, so all the same steps work even if you're working with decimals. So I just wanted to throw that one in. You will see some decimal equations in your homework as well, and you have seen them so far too. Okay, a few of them kind of thrown in there. All right, so my goal is that, again, just to see more examples of what to do when you're saying 8.3 really brings in a lot of these fractions, right? How do you handle getting rid of those fractions and still simplifying for x in linear equations? So what we're learning is the kind of my at least best method, and I think the method the book also uses, is to multiply out those denominators, okay? All right, so let's look at a couple applications here just to finish out. We've talked a lot about linear models, so we still want to use linear models and now use some of the tactics we've learned to solve linear equations to answer questions with those linear models. The first thing we're going to do is jog our memories back to constructing linear models. Remember, linear models are y equals mx plus b, where b is an initial value or our y-intercept and m is our rate of change. Okay, so we're looking for those in this linear model in this information that's been given. This one says that the sales of musical instruments were 6.39 million in 2010 and decreased by about 0.28 million per year until 2014. They want S to be the sales of the musical instruments in millions and T to be the years since 2010. So in this case, our output, right, time is going to affect the sales. So your linear model should be S equals, you're still going to look for that M, your input variable is going to be T, and you're going to add in that initial value. Now T is years since 2010. That would mean whatever I sold in 2010 is my initial value. So since I sold 6.3 million and my output is in millions, this B value here will be 6.39, since that's exactly what I sold in my initial year, which was 2000. Now I have that one number left, right, which is probably going to be what I need to use for M. M's kind of always the harder one to find. Here I don't have another point that I need to use to find slope. Here I'm told that it's decreasing by 0.28 million per year. So every time I multiply by the year, I need to decrease by 0.28 million in my sales. And that will give me my linear function there. You just have to be able to pull out that information. I don't mean just, that's a hard task to do, but the more you do it, the more you'll understand what these numbers mean. Okay, so we've translated this scenario into the correct variables, the correct slope and y-intercept, and we have our linear model. And now the awesome part is we can use this model to estimate in which year sales will be approximately 5.3 million. And we're going to use those tactics because we know here this is the sales, that's S. So we're going to be solving for the variable that's not already by itself. We want 5.3 to equal negative 2.8 times our input variable plus 6.39. So we need to do a little bit of work to get this t value by itself, right? But we know how to solve these linear equations now. We know that we first need to move the constant over to be with the other constant. So we first need to take 5.3 and subtract 6.39. If we do that, we will end up with negative 1.09 equal to negative 0.28 times t. Negative 0.28 is being multiplied by t, so I need to divide, oops, not by 2.8, but by that number I see, 0.28, divide by negative 0.28 again on both sides. And you'll get a t value. This is not a nice number, right? It's a fraction that goes on forever, but we're just estimating in which year. So I'm going to go ahead and just round to the nearest year here, and you'll get guidance on that in your homework and stuff like that. Okay, since we're talking years, I'm going to round to the nearest year. That would be, you get about 3.89, so I'm going to round to t equals 4. Okay, now that doesn't quite answer my question, right? It asks in what year, so that would be approximately, remember it's years since 2010, so we'd have to take 2010 plus that t value we get to realize that we're estimating that this will happen a little bit before, right? Because we rounded up, it'll happen around 2014. Okay, so we can use those linear models now and actually solve for some of the input variables, since we know how to solve for we know how to solve for those variables now that aren't by themselves. Okay, another good example and another kind of harder one to set up these equations with are with percentages, not quite like the ones we saw in 8.1 and 8.2. So these are a little bit more complicated percentage problems. So I wanted to make sure to look at a couple of these. Okay, you're going to see these in your homework as well, so you're going to get good practice. This first one about percentages says, in 2014, worldwide sales, in 2014, worldwide sales of digital cameras were 43.4 million. That was down 31% from 2013. We want to know what the sales were in 2013. So take the time, that's a lot of information, right? What should you do first? Always look at the question and set up a variable so you can make an equation to make sense of this information. We want to know the sales in 2013. So X is going to be the 2013 sales. Then we go back. In 2014, worldwide sales of digital cameras were 43.4 million. So 43.4 million is something we know. That is something, right? That was down 31% from 2013. So this is where we have problems probably, right? Translating this into an equation. So the sales were down from 2013. So we had the sales in 2013 and now they're going to go down. They're going to go down by 31%. Remember though, 31% needs to be as a decimal, and percentages should always be multiplied by something. If we're going to go down 31%, we're going to go take 31% away from the sales that we have. So that's how I would represent something that is down 31%. Okay, so I took my sales from 2013, I took away 31%, and that gives me my sales in 2014. Okay, and now I have an equation I can solve. Notice the steps you should take here. You have two x's on one side. Those can be combined. So 43.4 equals 0.69 times x. Okay, you get the 0.69 because there is a 1 sitting in front of this x here, and 1 minus 0.31 is 0.69. Okay, that's an important step there, is to realize that 1 is sitting there. Then here we just have that one last step, divide off what is being multiplied by x. And again, we're not going to get a nice number here. We're talking about sales in millions of dollars here. The first one we were given was rounded to the nearest tenth, so I'm going to go ahead and round this one to the nearest tenth as well. 43.4 divided by 0.69 means that my original sales, X in 2013, was 62.9 if I round to the nearest tenth, and it's asking me what were the sales. This isn't your final answer then, because I know that needs to be in millions of dollars. Okay, so make sure you add those units onto your final answer. Make sure you put them in terms of the rest of the units. Now notice this number is bigger, always a good double check. This number should be bigger because we went down from 2013 to be down to sales in 2014. So we needed to end up with a number that was bigger. So that's a good double check at the end. So let's see how this kind of works also with going up. If a percentage increases, what do? A similar setup occurs, okay? So let's look at this last example here for these notes, and we're gonna figure out if in 2013, total MasterCard debit purchases were 491.1 billion, and that was up from 2012, and we want to find what were the total purchases in 2012. So again, set up your variable. X is going to be the purchases. Sorry, that's fairly illegible. Let me try that again. Purchases, there we go, that's a little bit better, in 2012, because that's what we want to know. Notice our other purchases were in billions, so maybe make that note to yourself so you don't forget that step at the end. These purchases are also going to be in billions since my other purchases were in billions. Now I go back to and I read through and I set up my equation. In 2013, the sales were 491.1. That is up 9.5% from 2012. That means we have our 2012 sales, and now that this time that it's up, we're going to add in a percentage of those sales, specifically 9.5%, which as a decimal is 0.095% of those sales. So we had the sales in 2012, they went up by a percentage of those sales to be our new sales in 2013. All right, so if the sales went up, we're looking for X to be less than 491.1. Let's see if we can get that. Here again, we have a 1 in front of X, so we're going to add 1 plus 0.095 to get 1.095 times X, and then that's being multiplied by X. So we will divide by 1.095 on both sides. Definitely need to grab a calculator here. Take 491.1 divided by 1.095. When you do that, again, this was rounded to the nearest tenth, so I'm going to round my answers to the nearest tenth. $448.5 billion is what we get for X. Okay, so if you go up by a percentage, that's kind of what your setup looks like. And if you go down by a percentage, that's what your setup looks like. So a couple good examples there. And again, you're going to do some more in the homework. So make sure you reach out if you're stuck, okay? Use that Ask My Instructor button. I'm not getting a whole lot of questions that way. So I've got plenty of time to answer your questions. So send them my way if you get stuck. All right, we've just got one more section after this, 8.4, and then that's all the new material for this whole semester. So you're very close to the end, guys.